Hello everyone, welcome to the BigQuery technical overview where we'll take a tour of BigQuery from data ingestion, streaming, data governance, along with data quality, machine learning, all the way through our intelligent serverless infrastructure. So let's get started. The first thing we'd like to show is how customers can see all their data. Data lives everywhere and BigQuery can bring all your data together and process it at scale. So let's head over to BigQuery and see how this works. So I'm in BigQuery now. And the first thing I'd like to show is how we can ingest data into BigQuery. So this is a load command done in SQL, and we support all the popular formats up here: Avro, Orc, JSON, Parquet, Iceberg, and we are bringing in a CSV file in this case from our Google Cloud Storage account. So very easy to use, and you can do this through our CLI, directly through SQL or SDKs. We support also third-party ETL tools. So after we've run this command, we can see we've ingested the data down here and it's available immediately in BigQuery. So the next piece is creating external tables. So a lot of customers want to support querying their data on their data lake directly in place. If you have a data mesh or a lakehouse architecture, so it's important that we can query the data directly on storage. And in this case, we're creating an external table. And as you can see here, we have a connection. So this is actually a big lake table. So this connection allows us to abstract the storage away from the user, so users don't have direct access to the storage system, which is good for making sure people don't hard code paths to storage, and it keeps maintenance much easier. And in addition, with Big Lake, we'll see later on that you can do column and row level security on the files with your Big Lake tables. So after we've done this with Parquet files, again, we can easily select the data. So the third type of data access is creating an external table with Hive partitioning. So a lot of times your files will be organized in a Hive style partitioned. So if you're familiar with Spark, it will put a series of files in a series of subdirectories. And if we click on green here, we'll see we have a Parquet folder and we have a year and month folders. So we can represent that with this table. So we have our partitions here for year and month, and we have our partitioning prefix. And I'll go ahead and create a table so we can interact with data that was saved by Hadoop or Spark. And we'll go ahead and run this and we'll get our data. So very easy to either load the data or just query it in place. And then another format here is Iceberg. So if we take a look at this, this is an Iceberg table and we have our metadata. So Iceberg has a metadata folder along with the data folder, so we can go ahead and create a table over the Iceberg data, and we'll go ahead and run select star on that, and we can easily look at our Iceberg data. If you notice here, we're using a hard-coded path to a specific metadata file. Later on, we'll look at our Big Lake Metastore, and what this does is it will keep this up to date. So as you insert, update, delete, or change data in your Iceberg tables, this URI will automatically be updated behind the scenes. So you're always querying the latest data. So we also support querying data on AWS and Azure. So this was previously done. This created a bunch of AWS tables. So these tables are represented over here. They're the taxi tables on an S3 storage account. And we can go ahead and query this right through the BigQuery user interface. So we don't need to necessarily go to AWS and deploy anything. Everything's deployed for you, so there's no maintenance on the AWS side, and you don't need to log into a console over in AWS. You just remain right in the BigQuery user interface and go ahead and query that data. So a lot of times there'll be terabytes of data over in AWS or Azure, and what we want to do is write an analytical query to summarize that data. And then here we're doing a create or replace table, so it's CTAS statement, and we're ingesting the data into our local BigQuery instance in the Google Cloud. So this now has transferred the data, so it executed this SQL statement over in AWS and transferred the results back to Google Cloud, where we can now do machine learning and we can join to other data. So here's data flow. Data flows are serverless streaming system that will, in this case, we're reading in data from a pub sub topic, we're parsing the JSON, we're adding a product ID, and we're streaming the data directly into a BigQuery table. So this service will scale horizontally, and it also scales vertically. So we can add additional memory or CPUs to machines, so we can make sure that typically you have to keep scaling outwards. Here we can actually add memory to the machines in case we need additional memory during our streaming job. So we're processing to BigQuery over 3,000 elements per second. So let's go ahead and see how we can query that data. So this is just a BigQuery table, and we access it just like regular SQL statement. So there's nothing special you need to do. Data flows a PaaS-based service that's going to automatically scale, and then BigQuery is going to receive that data, and you query it just like any other SQL table. So something that's a little even easier than writing a data flow job is to create a BigQuery subscription. So since our data is in pub/sub, we're going to create this subscription. And this data can be either string or JSON. So you can use either data type. And then let's go ahead and create the BigQuery subscription. So I'm going to copy this topic, and we'll go ahead and create this subscription. So we'll create a subscription here, and let's just call it test. And we're going to enter the topic manually, and we'll save that. And then here we're going to say write to BigQuery. So let's go ahead and get our data set, which is taxi data set here, and we will paste this in. And we'll also get our table name, which is this pub/sub table name. And let's paste that in. Now, if you have a schema inside your topic, this will actually parse the columns parse the data into individual columns. So you'd have a strongly typed data versus what we're doing here is we're just taking the JSON payload and putting it in a table. So very easy to do. You don't need to even create a data flow job as we just saw. So we've created a BigQuery subscription, and let's go query the data. So we should be able to see the data instantly, and we have data arriving. So that quickly we have data arriving. And if we do a count star here, we can see that just in a few seconds we've imported, let's see how many rows of data were imported. We imported 47,000 rows of data. So this is great if you want to run machine learning on this data now. And also if you wanted to do alerting on the data, you could create something like an external function and send the results to an external function that could go into another pub/sub topic or go directly into an alerting system, so you can act on this data as quickly as you receive it. So another big pattern is change data capture. So data stream is our change data capture service. And in this case, we are querying a Postgres database. Let's go take a quick look at that. And we have our data stream job here. And we have two connections. One is from our Postgres, and then the other is to BigQuery. So we set up these two connections, and then we basically start the streaming job. And now we can receive change data capture from our Postgres database into BigQuery. So this is important if you want to do analytics at scale, or you want to do machine learning, or even historical reporting, because a lot of times you don't want to tax your underlying OLTP system with that overhead, or even scale that system, because sometimes you have to buy additional licenses and additional cores. A lot of times those systems scale vertically, so you have to buy a bigger machine. And the last piece I like to show is maybe you have data in Spanner or one of our Cloud SQL instances or big table. We can actually run a SQL statement. And in this case, we're going to send this SQL statement down to this Spanner instance. So I have a connection and I have a SQL statement. So we're going to write a federated query here, and I can show you this in the console. And let's see our Spanner instance. So this data is not physically in BigQuery. What we're going to do is send this SQL statement down to this Spanner database and execute it. So let's highlight that and give it a try. And we get our results back. So those are the basic ways, a quick overview of how we can get data into BigQuery. So now we're going to move on to see how we can trust our data. Once you have access to all your data, you need to trust it. You need to know where the data was sourced from, and you need to secure it, whether it's in your data lake or directly within BigQuery. So let's take a look in BigQuery. The first piece is data lineage. Customers have been asking for data lineage, and within BigQuery, you get data lineage free every time you run a SQL statement. So let's take a look on how this looks. So we're going to go over to our data catalog, and within data catalog, we have a table, and we want to see the lineage of this table. So you can click on the lineage tab here, and we can see each of our steps that ended up creating this table. So I'm going to expand these a little bit, and you can drill down all the way to the source data. So this will keep going all the way down. In this case, we're using iceberg tables, so we can see our Big Lake Metastore. And in this case, we have Analytics Hub data. So this was shared through a third party, and we can see that data. So you see the complete lineage, and you can also see the SQL statements that help create the lineage. So you have a complete view from the source all the way to the destination. The other piece for lineage is a lot of customers will orchestrate their data with Airflow. So we do offer a plugin for Airflow, so you can actually show your orchestration through Airflow and register that lineage with BigQuery. So that was lineage showing you through data catalog. And we also have a view here. And this is, I'll show you the same type of lineage, but let's do it directly in BigQuery. So you can see the lineage through a data catalog search or directly through the BigQuery user interface. So here's the view, and the same type of lineage experience you just saw is available directly within BigQuery. So in this case, I have Parquet files, I've brought in JSON files, I brought in CSV files, and I brought in additional JSON files. So it's very easy to drill down and see that lineage. So another aspect is managing this data. So you end up with data in a series of places where there's BigQuery in your storage system, and we want a way to organize it so we can easily secure it and make sure the data is governed. So let's click on the Rideshare Lakehouse here, and you'll see if we click on zones, you see we have a raw zone, enriched zone, and curated zone. So let's go ahead and click on the raw zone, and you can see I can register my storage buckets and my BigQuery data sets. So these are all registered here, and you can also see that there's warnings here indicating that I should go look that there's some type of bad information or maybe a storage account was deleted, so we know that information is being bubbled up to us. So we have that information, and let's go ahead and see, now that we have it organized, how do we go ahead and secure this data? So head back to here and we'll look at security. So security typically involves going to many different storage accounts, figuring out what data sets you need to secure. And if you're going to change the ACLs on millions or billions of files, that can take hours. So once we organize the data into our data lakes, we can go ahead and we can set security inside of these different zones. So here, for instance, I have a user, and I can also clear this, and I can see all the users that have access to each of my zones. So this lets me drill through, easily grant permissions to maybe, granting a reader access to a curated zone, or I could grant reader-writer access to a raw zone. So since we're going to get thousands or lots of users in our system, we can also go to a principal-centric view. And in this case, I can click on the user, and I can see directly what that user has access to. So instead of clicking around trying to find a user, I can simply say they have access to a reader role to this data lake, and then inside the curated zone, they're a reader, but in the raw zone, they're a data owner. So very easy to go ahead and set that, and that will propagate through the various systems. So you're not hunting and pecking, trying to find all the storage accounts or some places or folders and setting those ACLs individually. So now that we have our data secured, Dataplex offers one additional benefit, is it does data discovery. So if I run this statement, you can see over here I have these data sets, and I have this random suffix. So these are data sets that were discovered by Dataplex and registered as BigQuery tables. So previously I went and imported data into BigQuery, or I registered tables. In this case, BigQuery is going to actually discover these tables and surface them up to my users so I can go ahead and query them. So I know you have typically will go ahead and create a big lake table, but Dataplex will actually go ahead and create those tables for you. So there's two options, but it definitely makes data easier to discover, and it also shows up in your data catalog. So after you have this data, we want to check our data profiling. We have two pieces part of Dataplex. One is profiling our data, and the next is data quality. So our profiling, we'll go ahead and click on that, is going to scan a table and show us the statistical characteristics of our data in this table. So as I scroll down, let me scroll down this way, you can see I see my averages, standard deviations. So what Dataplex has done is created a scan, or we can create a scan, and it will determine the statistical characteristics. It's quite easy to do. You come here, you click the browse button, and that same set of assets that we were looking at before, we can go ahead and pick a table and go ahead and scan a table. So you just simply select it, and you can do a sampling size, scan incrementally if you have a timestamp, and then we can go ahead and create that scan. So it's easy to set up, but what this really gives you a benefit for is for setting up a lot of complex data quality rules. So we have that scan. We're going to jump back here. We'll go over to data quality. So with data quality, we can also basically perform a check on each of our columns for each of our tables within Dataplex or within BigQuery. So what this data quality job has done, as you can see for each column here, we've done a null check, we've done statistical range checks. So this actually used the results of our profile to create this. But let's just go ahead and create one and take a look on how we can do that. So we'll go ahead and give it a quick test name, and we'll browse to a table. And we'll go to the rideshare lake house. I think it was curated zone, and our trip table, hit select. Again, you can do entire data or incremental, and you can repeat this. And let's go ahead to the data quality rules, and we can click add some rules. So we can add rules based upon a profile. So this is my profile that I ran here, and it created all these rules based upon my scan. That's a very easy way to get started. Or you can do built-in rules, like for instance, we have null checks, regex expressions, and then you can also do SQL statements, so SQL row checks. So any type of SQL expression you want to paste in here will actually execute as a rule. So the data quality will run, and then you can see those results. And over here, I'll show how we can inject those results into data catalog. So this is that same table. But what I did is I sent the results over to data catalog. So now my users, when they search for my table, you can see we see the data quality summarization. And if we click on the schema, we can actually see the results at each for each column within that table. So data quality is easy to schedule, and that's very easy to set up with a profile. So you can point it at your clean production data, generate a profile, and we can use that to scan your additional data. Now, one last piece is we can secure the data with Dataplex, but we still want to secure individual rows, columns, and also to data masking. So we're going to create a big lake table, and we're creating this over a CSV file. So let's go ahead and select that, and we'll see the results. So the results here show that we have our CSV file queried, but now what I want to do is go ahead and create a row level access policy. So this is going to filter rows to Manhattan. So let's go ahead and rerun this and see if we get our data filtering. So it's going to warn us that we only have access to certain rows. And basically we can do users, we can do groups, but we're applying a row level access policy. And this works for internal tables and external Big Lake tables. So this is a standard CSV file that's not been ingested into BigQuery, and we can apply these policies to it. We can also go ahead and let's scroll down here and find it, create the table. We can also do column level security. So if I click on this schema, I can add a policy tag here. And then here I could do a business critical. Let me click this project here. So I can do a data masking rule or high level security, which my user doesn't have access to. And when I run that, I should get an exception that I don't have access to that. So if I run that now, we should be disallowed. So I'm getting an error because I'm trying to select star and I don't have access to that particular column. So very powerful. It's all integrated security. So you set this up, you can set it up through Dataplex, apply your row, column, or data masking rules, and your entire data lake or BigQuery data sets are secured. So this is the same code, just really illustrates that's the exact same thing for doing an internal table. So let's jump back to the slides. And the next part is we'll see how we can activate our data. Now that the data is loaded, clean, and secure, we can act on it with machine learning, search, and even do unstructured data analytics. So let's head over to BigQuery. And here I created a model. This is a logistic regression model, and we're trying to predict customers who are going to churn on a website. So it's very easy to do with a SQL syntax. So we have different models we support in BigQuery. There's some links up here, but we support logistic regression, boosted trees, deep neural networks, classifications, AutoML, and others. And you can also do L1, L2 regularization, splits, dropouts, and other hyperparameter tuning. So everything you can do for the most part in a notebook, you can come over here and do it within BigQuery. So once we have this model, we can click on it in BigQuery and you can take a look at the evaluation. So the model is stored in BigQuery, but I've also exported to Vertex AI. So that's our AI platform, and we'll take a look at that in a moment. So the next thing I want to do is score it. So scoring data is easy as running a SQL statement. So here I'm doing a explain predict, and this is using explainable AI to predict which features contributed to this score. So having explainable AI is really important, especially if you have to comply with new laws and regulations. And doing a prediction in a SQL statement makes it very easy to score billions of rows of data in BigQuery, because typically customers will need to export the data out of a warehouse, score it with some type of script, and then they have to load the data back into the warehouse and update the original table. So this saves that whole effort, where you can just do a update statement and do a prediction directly on that data. So let's go over to Vertex AI and take a look at the model registry. So here's our model registry, and we can see we have different versions of this model, and I can go ahead and click on deploy to endpoint. So in addition to having this model available within BigQuery, maybe you have some custom app dev projects that want to call a REST API endpoint, and we can go ahead and deploy this to an API endpoint. And one of the benefits is we can also do skew and drift detection. So these are key indicators that the data we're receiving doesn't fit what we trained it with, and that we should do a retraining activity. So you can either consume the model directly within BigQuery or go ahead and use the Vertex AI model registry. The other option for models is to import a model. So sometimes you might have have a model that you built outside of BigQuery. Let's take a look at one. So this is a deep neural network model that was built inside a notebook, and I wrote this out to a storage. So we're going to skip over the notebook. So I ended up with this path here, has my linear regression model here, and I'm going to go ahead and bring that into BigQuery, and we'll be able to run predictions now within BigQuery. So we support different formats. Right now we have TensorFlow, TF-Lite, XGBoost, and Onyx, and we're going to also enable sklearn, PyTorch, and SparkML. So once that model is in here, you see it's imported over within BigQuery, and we can go ahead and run a prediction, and this would give us the same exact score that we did in our notebook. So very easy to bring your model to your data. And also this helps with like reporting tools. So a reporting tool, if you wanted to score 1,000 rows during the execution of a report, you can just put this predict as a column within BigQuery in your report SQL call, and it alleviates trying to have a reporting system called REST API endpoint or somehow ingest the model into it so it could do those predictions. So you can just pop this in a view, have the prediction, and then you'll see your scores directly in your reporting tool. So the next thing is time travel. So BigQuery has always had time travel. Let's go ahead and create a table. And this table will just bring in some data. And time travel is important for a lot of different things. Sometimes you might want to be loading data into BigQuery and you have views pointing to a specific point in time so the users don't see the new data. Or we can actually use it for going back and looking at, it goes back 7 days. So you could look at point in times for 7 days. And in this case, we're going to go ahead and delete data. So you can delete data, or you can drop an entire table, and BigQuery preserves that. So in this case, we'll go ahead and delete some rows. And typically with this, you'd have to restore a database, find the one table, and recover those rows. Here we can quickly see that we have deleted rows. And now we can do go back in time 15 seconds and see that we have access to the original rows. So very useful for a lot of different things. And if you need more than 7 days, we do offer snapshots, and you can keep them as long as you'd like. So JSON's a popular data type within BigQuery. So we have JSON data, so we're going to go ahead and create a table. And this is very useful for people that store billions or hundreds of billions of rows of telemetry data within BigQuery. You might store it as a JSON object, and each row might have different attributes. So depending if you had telemetry for computer data or car data, you might have these different attributes that each have, and we don't want to create a column for every attribute. So JSON just acts like any other table, so you can just do a select star from it. We can see our JSON. It also has our partitioning from our storage, and we can use dot notation here to go ahead and reference those fields. We can also do analytics on it. So once you have all that data, here we're going to do ranking, partitioning, and do some analytics on this data. So we can treat this like a regular table with this with statement here. We're going to do ranking, partitioning, and we're going to order by. So this is a fairly complex query. It's going to take a few seconds to execute. And then we're going to go ahead and join that to the payment type table, and we'll see our results. And we'll go ahead and pick out the top rankings. So that takes about 30 seconds to do that on that data set. I'll show you how to speed that up in a second with Big Search. So here we have that pickup date, and we have the top payment types, the passengers, and the total amounts they spent per payment type per day with ranking and partitioning. So Big Search is another feature of BigQuery. So if you have lots of log data, you can go ahead and store it as JSON, for instance, IP addresses in the log data or email addresses, and it's intelligent about what's in that data. And then you can also do text-based searching to search for exact matches. So here we have 92 million rows of data, and we're going to search for credit cards. This query just simply finds a credit card number we can search for. And here, let's go ahead and search for a credit card number. And this is going to search the credit card field, and it's going to find that credit card number quite quickly. We can also search the entire table. So if we don't know what column it's in, we see we're specifying the table name here, and I can go ahead and run that same query, and this will search every field that's indexed and find that result. So to demonstrate this, we'll do a table that's not indexed. So this is going to go through about 5.8 terabytes of data. It goes through it rather quickly, but it has to go ahead and scan 5 terabytes of data. Now, if we do the same query with Big Search, we run this, it takes much, almost instant, and then this is scanning much less data. So adding search indexes, especially to JSON, lets you traverse that and quickly find data at scale. If we wanted to see this even at larger scale, here's 50 billion rows of data, and we're going to do a search for this service. So this is like a Kubernetes cluster that's running that has just tons of log files, and we quickly found data within a specific timestamp. So Big Search adds ability to find basically a needle in a haystack, because you can always partition and cluster your data, but sometimes you just need to go search a separate field directly. So one thing I'm really excited about is query acceleration. So I'm not going to run this query because it takes way too long, but what was done here is it's a data lake, and this table has been over partitioned. So this happens a couple different ways. Maybe your data lake just gets extremely large and you have trillions or hundreds of billions of files in it, or even millions in this case. We have 5 million files, and this data was over partitioned, meaning I was trying to optimize it to go down to the minute level, but I ended up with lots of small files. So it's typically known as the small file problem, and it creates a problem when systems try to query it, because the system spends a lot of time asking the storage system to give me a directory listing for all the files. It can take up to 5 minutes for 1 million files to get a directory listing. So BigQuery has solved this by using query acceleration. So this is the same query above that takes over 3 minutes, and this just takes, I think, a few seconds to go ahead and get those results. So the difference is this table has query acceleration enabled, and that means BigQuery is caching the entire directory structure of the Google Cloud bucket, the storage bucket, inside an internal BigQuery table. So this means BigQuery queries itself and doesn't ask the storage system for the list of files to go query, and it can do that very quickly. So it queries itself, and then it now has a direct list of files it needs to read in, and it goes and retrieves those files directly from storage. So query acceleration is great for huge data lakes or just over partitioning, lots of problems, and it's going to be exciting to see how quick it can scale trillions of files with this technology. The other piece is unstructured data analytics. So we've talked about doing analytics on columns, rows, and JSON, which is semi-structured, but what if we have images? So this is going to create an object table over this. So I'm going to go ahead and click on this link. And what we have here is a bucket, and we have images in here. If I click on the images, I actually have metadata as well. So I can edit the metadata, and I can see I have location IDs here. I'm going to hit cancel, and we have an image. So how do we find value in this? So I've created a table over this directory in BigQuery. I'm going to call refresh here for the demo so we don't have to wait, and this should go ahead and refresh it to the latest data, and we will see that we have each of these URIs. We have the content type, we have the size, we have hashes and updates, and we actually have our metadata. So I have now visibility, and this is a big lake table, so users don't actually need access to the underlying data to run these analytics. So I can see these, and now I can actually score these. So I'm going to go ahead and call a external remote function, and this is going to call Vertex AI, and soon you'll be able to not even have to call Vertex AI. It will just be built in. So you could score this directly within BigQuery. So here I've extracted cars and other datas from those images, and now I can detect. So maybe I want to say, find all the buildings or find all the pictures of Statue of Liberty on my storage system, and that could be trillions of files. So now we can use BigQuery to go ahead and write SQL statements to find item detections in those images. Or if you have sound files, wave files, you can transcribe them into words, and then you can then search those words. So here I'm searching for objects, I'm searching for labels, I'm detecting landmarks, and I'm detecting logos. So you can call any of those APIs or any custom REST API you'd like, and then use this data to do analytics. So the last piece here is calling BigSpark. So this is part Iceberg, part BigSpark. So I'm going to jump over to another tab here. And this is a basically Spark code. So this code is just Spark code, and we have a header here that is a BigQuery store procedure. And this allows us to now do Spark coding directly within the BigQuery user interface. And there's lots of use cases for this. Maybe we want to have some custom Spark code running, or there's something in Spark we'd like to access from BigQuery. So we can go ahead and author that directly within BigQuery. And in this case, I'm going to highlight the Big Lake Metastore. In this metastore, earlier on in the demo, we saw we hard-coded our path to a JSON file for our Iceberg format. And this Big Lake Metastore is going to let us now create a Iceberg catalog and warehouse, but then we can create tables. So we're going to go ahead and create Iceberg tables here. But what we're going to do is tell BigQuery and register this table with BigQuery when we're creating this table from Spark. And this means Spark is interacting and creating Iceberg tables or doing inserts and updates. And now BigQuery with this table properties with the Big Lake Metastore will stay in sync with your Spark inserts, updates, and deletes on those tables. So two things here. One, you can run Spark code in BigQuery, and two, the Big Lake Metastore supports Iceberg, where we can keep up to date with all the changes with all the various updates going on to your data lake. So we'll go back to the slides for a second. And the next piece here is our intelligent infrastructure. Now let's see how BigQuery uses its intelligent infrastructure to make running BigQuery easy. So I'm going to head back to BigQuery. And the first thing I'd like to show you is autoscaling. So this is a new feature of BigQuery where we can actually scale your workload in flight. So unlike other warehouses where they add another compute node, they expand the number of servers in their cluster, or they have to actually create a whole new cluster, BigQuery is serverless, so we can simply add compute to an existing workload. So we have the ability to specify the number of slots we might want. So I could say I want 200 max slots, and maybe I want 100 slots running at all times. So this will let you choose between a min and max, and your baseline could be 0, so it could be pure auto scale. So definitely check this out. This is allows us to basically match as close as possible the number of slots you require to the workload that you're running. The next piece is monitoring. So we'll click on that and we'll go to monitoring. And here I can see, for instance, I have on-demand utilization within my project, and I can go ahead and choose multiple regions and look at my org. So I can look through reservations, on-demand pricing, and filter this down to specific projects to see how many gigs I'm scanning and how much I have to pay for that. There's also an operational health, and this is going to show overall the resources that are running within my various projects. And in this case, I don't have many resources running, so it doesn't show a lot of interesting data at this point. So you can definitely check out those monitoring dashboards in your project, and we'll show you a lot more information, especially specific to the queries and jobs that you're executing. So the other piece here is maybe we want to see even on a lower level. So this query is going to show me per on-demand job or each job. For on-demand jobs, it's actually going to show me a price, so I can compute the price, and it's going to show me the reservation that was used. So for every single SQL statement that's run in BigQuery, we can go ahead and see how many slots were used, and we can actually compute the costs per query. So for instance, this query is 0.0003 cents. So I can see that SQL statement, and now I can do things like see which SQL statements are being executed over and over, and I can sum up those costs, and I can do that per project. So you have the ability to monitor this at your monitoring dashboards, but you can also drill down to our informational schema tables and see the exact SQL statements, who's running them, how long they're taking, and how many slots they use. So one question I get asked a lot is how do you make sure that you're not spending too much in BigQuery? Well, if you buy slots, then you pay for those slots and you can run as many queries as you want. Our other model is on-demand pricing. So we charge you a certain amount of money per terabyte scanned. So in order to avoid going over and spending a lot of money, you can come in here and set, I only want to pay for 50 terabytes a day scanned and lock in your price for on-demand usage. Or you could say, I want each user to get a $5 a day quota. So you could compute that, the number of terabytes, and then each user can only run that many queries. So you know your costs won't exceed a certain amount. So we definitely have controls to help you through all that. The next piece is query visualizations. So we can actually see a visual query plan. So typically we show you the execution steps, but we've added a execution graph that will let you see your bottlenecks and how to help fine tune your queries. So here you'll see I have a graph. I'm going to zoom out a little bit, and we can see that 17 million rows are being moved from point A to point B. So this join is taking up the majority of my processing, and then I can look at how to optimize that step. So we do have visual explanation plans as well. So once you've been running BigQuery for a while, we're going to go to the slot recommender, and we will see how many slots I should buy. So a lot of people start out with on-demand pricing. They run a lot of queries, and after a while they have a sustained workload. We're not going to see too much interesting stuff for me because I don't run a sustained workload, but we can see all my on-demand usage, and then it's saying recommendations are not available at this time, which makes sense since I don't have a sustained workload. But this slot recommender will show you how many slots you should purchase, and then you can model it with different number of slots because buying less slots might affect your performance. You can see I peak up to 6,000 slots here. So if I purchase less slots, that query would possibly be taking longer. So this would help you see the impact on your specific workload. The next item is how do you see all this data? So I'm going to jump over to a website that uses, under the cover, it uses Looker. So let's go ahead and load that up. So I thought I had it loaded, but we will load it up and take a quick look. So here I'm going to this website, and I'll click on sales overview. And then all this data is in BigQuery, but a lot of customers like putting a semantic layer on top of BigQuery. And what this will do is let you put business terms over this, and then Looker will generate the SQL for you. So here I dug in and I hit the explore command, and I can type the word age in here. So I can find the word age, and I can simply run that, and it adds it to my map. You can also click on the SQL, and the SQL will show you that's running. So in addition to being able to do this all directly within BigQuery, it's nice to put a semantic layer on top of this, and now we can go ahead and run this through Looker. couple pieces left here is translate. So a lot of people are going to, come from different systems. So let's go ahead and do this. We'll go to enable SQL translation. And I have a sample query back here. We'll copy this. And what this will do is do you inline translation. Let me copy the right stuff here. Sorry. Copy this and paste it over here. And this should do inline SQL translation. So I can hit translate. It will take this Teradata syntax and convert it to BigQuery. And we also support all these other formats. So you can do this interactively like I'm doing, or you can place a whole series of SQL statements in a storage bucket, and we'll run a job on top of that and give you the output. So it helps you come over to BigQuery by offering that translation. So we also have built-in support for Sheets, and you can also do this in other tools, but it's quick and easy in Sheets. So if we come over to Google Sheets, I can connect to BigQuery, and let me quickly just grab this project ID since I have a lot of projects, and we'll be able to quickly find this one. Here we go. This is a project we're working in, and we will go to the taxi data set. And this table has 170 million rows of data in it. So we'll do taxi trips and we'll hit connect. So this is gonna easily connect BigQuery to Sheets, so you can do even additional ad hoc analysis. So this is calling over to BigQuery. It's getting the data. So we now have 183 million rows that we have access to. And then you can do easy stuff like create a pivot table. So here, maybe I'll take a taxi company and I'll stick that in rows, and we'll take the total amount and add that to values. And then we can hit apply, and this will execute a query in BigQuery to summarize that data. So very easy to go ahead and expose that either through Looker with a semantic layer or just using Sheets to do ad hoc exploration. So the last piece is BI engine. So as you get lots and lots of users in here and you have a high degrees of concurrency, what we can do is do BI engine on top of your BigQuery. So this is going to let you buy capacity, and this will cache specific tables, or BigQuery itself will actually figure out which tables to cache, and then we will scale your concurrency to thousands and thousands of concurrent users by having this hitting BI engine, and Looker integrates with this so we can get intelligent caching. And you don't need to go and deploy a separate OLAP tool to handle this. It's built directly into BigQuery. So I think that's everything we wanted to cover, and here's the summary slide. I hope you enjoyed this overview, and thank you for watching.